So hello everyone, and thank you for joining us today for our safety webinar on proper use of shackles. This webinar is back by popular demand. It has been the most viewed YouTube safety webinar in the history of our company. So we decided to bring it back and have Peter present it live once again. My name is Gisela Clark. I'm the e-marketing specialist at Columbus McKinnon and will be your host for today's webinar. Presenting today will be Peter Cook. He's our training manager at Columbus McKinnon. Peter started our hands-on training program from our original CM factory in Tonawanda, New York, and encouraged certification for rigging and cranes. He helped the NCCCO and CIC develop certification for riggers. Peter has also been involved with ASME B30.9 to help write sling safety standards. Peter, if you can please advance to this slide where we talk about some of the logistics for today. Perfect, thank you. Before we begin, there are just a few things we'd like to cover. We will be recording the session today, and the recording link will be added to our YouTube channel. All in attendance will receive a link to the recording. Look for it in your email within the next day or two. Everyone is in listen-only mode, so we encourage you to ask questions in the Q&A pane on the right side of your page. We'll take 5 minutes at the end to answer your questions. Since we have so much participation today, I think we'll allow more time. So if you need to jump off at the end, feel free to, but we will take all the questions, as many as come in today. So just if you're interested, you can hang with us and we'll take all of them. Lastly, after each webinar, we will select one of the questions to be used in our blog the following week. If your question is chosen, and we may even pick two, we'll send you a Columbus McKinnon promotional item, something like a shirt, hat, work gloves, something like this. So please participate, send us your questions or type in your questions in the Q&A pane, and we'll ask them at the end of the webinar. So we appreciate your attention, and now I'll turn the meeting over to Peter so that we can begin.
Thank you, everybody, and good morning. Just for a note there that these presentations are no substitute for OSHA regulations or safety regulations and standards that are out there. So we do encourage you to seek those standards and specifications out, as well as contact manufacturer for any additional information. So we'll get started. So today we're going to define shackle types and configurations, shackle identification and marking, shackle inspection, safe rigging practices with shackles, and then again, like Gisela said, we'll take any questions that you may have at the end. So when you buy a shackle from Columbus McKinnon, what we do is our shackle meets a variety of standards. So there's a lot of quality and engineering that goes on, even though you look at it as a simple forging. Really, we can probably stack a pile of books, 2 feet high, that we go through to meet certain standards, so that you have a safe product in the industry, so that you're getting a quality rigging hardware from us when you get that. Okay. So the types of shackles that are out there, and these are the most common. You have a screw pin anchor style shackle, and the shape of that body, kind of see that's what they call an anchor style. I'm not quite sure where the word anchor style came from, but that's when someone says anchor style, that's where it came from. Bolt nut cotter style shackle, you can see there, it's a little bit more secure, has a pin with a bolt nut and cotter in it. So that we use for more semi-permanent applications, where the anchor style, screw pin anchor style, is more of a you take it off every time you rig. And then you have a chain. A smaller type of shackle is a chain style shackle, and you can get that screw pin or bolt nut and cotter style. So why would someone choose the screw pin style? Well, it's easy to remove. So this is probably one of our most popular kind of shackles, a screw pin anchor style shackle. You can get it painted, you can get it galvanized, self-colored, you can get it in black if you so wish. If this type of shackle is going to remain in place for any specified period of time, then we recommend mouse tailing the shackle. Really, if it's going to remain in place for longer than the lift, or like a semi-permanent application, the bolt nut cotter is the way to go. But if you have these shackles and you need to remain in place, we do recommend you do what's called a mouse tail.
Hey Peter, what size wire do you need for a mouse tail, and how would someone go about doing this?
Well, there really isn't any specification what size wire. You know, you want something that's, you know, that you can work with, that will bend. You know, will bend. You might want to see the hole. There's a hole in the shackle pin there. That hole actually is there for a spanner wrench so that you can loosen the shackle up. But you might want to wrap 2 to 3 times around. Go through the hole, go through the pin. So something that's adequate, but not something that's too difficult to work with. You know, again, you want to make it easy on the riggers to do. So something that just kind of stops that pin from loosening up when it remains in place.
Okay, great. Thank you.
Good question. And we get that asked quite a bit. Yeah. Okay, there's your bolt nut cotter style. Again, a more permanent type, semi-permanent type for applications where it's going to remain in place. That's the style you want to use, and you always need to have that cotter in place so that it secures that nut from backing off. Okay. And then you have the chain style or D shape. We call it D shape or chain style shackles. You can have bolt nut cotter. You can have screw pin style of that. They're a smaller type shackle. They always have to remain in line. There's absolutely no side loading allowed with these. We also have one that's called a long reach shackle that is used for applications where a hole or attachment is quite a ways down, and so it has the same type of shape, but more for inline loading only. Okay, then we come up with a round pin style anchor shackle, and the round pin really is not recognized by the ASME B30.26. So this is more for tensioning, pulling, load securement applications when it's not an overhead lift. So basically the rule is if the pin or the pin doesn't have a thread, or the body is not threaded, or you have a bolt nut cotter, then you shouldn't use it for overhead lifting. So in the event that something were to strike up against that pin, you only have that cotter there and the pin can come out. So we do not recommend that for overhead lifting.
Hey, Peter, I'd like to go ahead and do a polling slide if that works. We're going to ask the question. Let me just pull it up. So what type of shackle should be used for overhead lifting? Is it a carbon, super carbon, alloy, or all of the above can be used? If everyone can vote, if you're on an iPad, you won't be able to, unfortunately, but you can send me your answer on the Q&A pane if you like. But everyone else should be able just to tick it off and vote. Great. Give it another couple seconds. So again, what type of shackle should be used for overhead lifting? Carbon, super carbon, alloy, or all of the above can be used. Well, Peter, it looks like it's between a few people mentioned carbon, but it looks like it's 30% alloy and about 66% believe all of the above can be used. Can you share the answer?
Yeah, well, 66% is correct. All of the above can be used, and it gets a little bit confusing because when you talk about the chain slings and things of that nature, we recommend only alloy chain slings for overhead lifting. But for shackles, you can use carbon, super carbon, and alloy. CM, by the way, is the only one that offers a super carbon shackle. In reality, it's a better carbon shackle with alloying elements in it. It's not quite an alloy shackle, but it's not quite carbon, and we call it a super carbon, which gives us higher working load limits, higher than, kind of an in-between for basically the same price you can get a carbon, so it's a step up. And I'll get into that a little bit. But all of them have different work limits. So physically, size for size, you could have 3, let's in this case, 7/8 shackles laid out on the table, and unless you looked at the embossing and the working load limit, they're going to have, that's the only way you would know what to use. You can't just rely on the size of the shackle for the working load limit. So you need to look at the embossing because you have 3 different types. So here you can kind of see in a chart between them and what the difference is in work limits. And let's just pick out 7/8 there. You can see the 7/8 shackle with carbon is 6.5 ton, the super carbon 8.5 ton, and the alloy is 9.5 ton. And then they have design factors. Carbon and alloys have a 5-to-1 design factor, and our super carbon has a 6-to-1 design factor. So for ease of explanation, let's say a shackle has a 1,000-pound capacity. The carbon and the alloy at 5,000 pounds, it would start to deform. That's where that's where the shackle would start to deform. Where a super carbon is 6-to-1. Obviously, no overloading is allowed whatsoever. This is when I go back to that original slide, I talked about the quality and the standards that Columbus McKinnon meets. That's what that's what allows you to have in the event something bad were to happen. Again, things can happen beyond our control, and Mistakes happen, but we always want you to stay always within the work limit and figure out what your tensions are and things of that nature. But just kind of give you an idea of the design factors there, which is interesting. Okay, so super strong versus a carbon. So why would I want a super strong over a carbon shackle? Obviously, to achieve a higher work limit with the same shackle size, that's always a good thing. I don't have to go up. So therefore, it'll fit, maybe fit in the same hole in applications where a larger shackle would not. When you maybe need a smaller shackle with the same work limit, that's just the opposite. You don't have to have the expensive alloy. Okay, so you have the price of a carbon, and you don't have to go up to pay the high price of an alloy, which can be a little bit more money. And then, again, that higher safety factor, that 6 to 1, or design, we should say design factor, if you will, and that's always a good thing. Alloy always being your best, of course. So alloy is going to give you the best properties, and especially in cold weather situations, going to give you a little bit more stretch. It's going to be your strongest. It's got toughness and things of that nature. So alloy is always your best. Super carbon and then carbon. Okay. Again, all good quality shackles, but you kind of have a good, better, best type situation. So again, comparing in a shock load test. Again, we don't never recommend, we try to avoid shock loads, but again, these things can happen in the field, and when compared to carbon, by far the super carbon outperformed any carbon shackle, whether it be CM or a competition. It certainly did outperform it again. So we kind of push our super carbon, majority of them, to our customers. We feel that's our best bet. And of course, we would not want to avoid the others, but that's pretty much the one that we really prefer. Okay, shackle identification and marking. So what's required on a shackle is the size of the shackle. You can see on the body there at 7/8. That's required. The name of the manufacturer, is the unique name of the manufacturer, that's required on there. And of course, the working limit of the shackle is all required. What's not required is a serial number. Now, a lot of people want to start inspecting shackles and things of that nature, which you can, but no written, you should, which you can and you should. And the rigger should be inspecting each and every lift. It doesn't take long to inspect a shackle. But for those that want to document and maybe serialize or have some kind of identification system, what CM has done, you can see here, and hopefully you can see my arrow there on my screen, is they created a raised pad where you can then stamp a serial number in the shackle. And you can go one step further and you can get RFID on the pin. And so an RFID chip, you can serialize that shackle and match it up with the body. So there's a lot of things you can do if you want to go that extra step. So those in the Navy or in the nuclear world, they have a pretty stringent system, and that helps them a lot for tracking and inspections and things of that nature. So, well, a couple of things, even though it's just a forging, you can make the shackle sophisticated by offering RFID and serializing it and creating inspection reports for them. So there, like I said, name of trademark, manufacturer, rated load, and the size. That's all required by ASME B30.26. I have seen shackles out there where they're kind of second-rate shackles, if you will, and they may have the country of origin on there, and that's it. And that the country of origin is not the manufacturer. So they have the work limit, they may have the size and a country of origin, or no manufacturer at all, so you don't even know who made it. So therefore, who do you call when something goes wrong? Who do you call for answers? Who do you call if you have technical questions? And so, and that, again, the very first slide I showed you was look at the quality that CM puts into their forgings. Again, it'd be a stack of books about 2 foot high, and we have this regular quality process and things of that nature. I forgot to mention that our shackles are made in Chattanooga, Tennessee, and we encourage anyone that wants to visit our plants can see shackles in action and see them being made. Certainly would welcome anyone to the plant there. All right, so we talked about the bodies a little bit, but then we have the pins. So we have the pins are identified as well, and that's, again, another sign of a quality shackle is look at the pin. The pin has to have an identification mark on it. You can see we put CM and HS, that stands for high strength, and we have a trace code on the pin. We can also offer RFID chips within the pin as well. But we have 3 different types of shackles, correct? Carbon, supercarbon, and alloy. So what at the end of the day, we mixed up our pins. We had all 7/8 shackles, and our riggers, they're working and they're just tossing the equipment. They're maybe taking down their rigging and tossing their equipment into a box and not really paying attention to where the pins are going. So you want to go reassemble. Oh no, now our pins are mixed up. What do we do? Which one was alloy? Which one was carbon? Which one was supercarbon? Well, it doesn't matter, because all our pins we make high strength. So in essence, you're getting an alloy pin with your shackle. Any of the shackles that you get, so you're getting a high strength alloy pin, so that it doesn't matter if you had mixed up the pins at the end of the day.
Hey, Peter, I've got a couple quick questions I think I'm just going to take now. This goes back to the pad that you just talked about in the last slide. How deep of a stamp can you put into the pad? And wouldn't stamping the shackle with a punch compromise the shackle? Can you just answer those 2 questions quick?
Yeah, we actually have a procedure laid out for that, so we can supply that for you. Obviously, you can tell by looking at the shackle how deep the pad is. Obviously, you wouldn't want it's a raised surface, so it's obviously is not going to cause any problems with the shackle. Where in years past we didn't have that, so we always kind of cringed when someone wanted to do any type of stamping on the shackle. You're really creating a nick or gouge. So for quick and dirty, I wouldn't go any deeper than what the thickness of that raised pad is. When you look at the shackle, you can actually see it, and so I would stay with that. But we can, CM actually has a procedure for that, and we can supply that.
Okay, and then okay, perfect. Thank you, Peter.
Okay. So kind of an actual picture of one of our pens. You can see the trace coating on there, the CM name, and the high strength. Again, another sign of a quality shackle. Even every part of that is labeled so that you know that you're getting quality parts inside it. So think about that. Well, next time you look at a shackle, you don't know who the manufacturer is, and then, where did that pin come from? There's no markings on the pin, no traceability. These are all things that that you want to be sure are there, so that when you're choosing a quality product. Okay. B3026, what they say, shackle users shall be trained in the selection, inspection, and cautions of personal effect of the environment and rigging practices. So basically a trained rigger. So we do offer rigging training that you can learn about shackles. This seminar, this helps this training as well. And we can actually come to us, we show you how to use them hands-on, and there is probably 100 uses of a shackle, how it can be used in different applications, and so that's, we're going to touch upon them as we go through here. Also, per B26, a visual inspection shall be performed by the user or other designated person each day before the shackle is being used. So basically, that's the rigger. The rigger needs to know, a qualified rigger, is the shackle safe to use? Are all the parts there? Is that a quality shackle? Are all the markings there? Okay. And so that's important. So semi-permanent shackles in accessible locations where frequent inspection are not feasible shall have what's known as a periodic inspection. So if you need a lift to get up there, obviously we can't inspect it each and every lift. And so an inspection criteria called periodic inspection is a general, you're going to have to set times where you're going to go up and look at that shackle, and that's based on the application. But hey, could be every month, could be every 4 months, could be yearly, but it has to be specified. So what's a periodic inspection? It's a complete inspection performed by a designated person. It shall not exceed a year. Written records are not required. Obviously, these shackles are not serialized, so how would you keep track? So again, one way is if you want to have written records, again, the stamping that CM allows with their raised pad surface and RFID, that would help you keep written records if you so wish. For those, and I'm just going to make, my opinion, and my opinion is only my opinion, and so don't confuse with any standards. But, if I was, for those and anyone on here on the entertainment industry, that might be something to think about, having RFID and serializations, just for the nature of where the shackles are used and basically suspended equipment that are overperformers and things of that nature. So that may be something to think about to do that. Again, that's my opinion. So why would I discard the shackle? So what are the things that I'm looking for to be sure that either I'm going to take it out of service or the shackle is safe? So you're going to look for wear, and any component that's worn 10% of the original dimension we want to get rid of. Nicks, gouges, any distortion. Check the pin. Is the pin threading on the body? Now I'll probably have another slide on this. I think I do. Let's talk about the pin. And sometimes people will take a shackle, I say, the pin fully seated or fully threaded. Now, a shackle is a forging, so a couple of things. What I really would look for is, does the pin thread in nicely, and do I get full engagement with on the body itself? So basically, if I had a screw, in that example, I have a screw pin shackle, so if I look on the body on the other side, I want to see that pin flush, or it might just stick out slightly, maybe 1/8 of an inch, if not, but flush, or about 1/8 of an inch. But if it was recessed within that body, then that would cause me concern, saying, well, why won't it go all the way through? There must be something wrong with it, or must be some distortion. But not always are you going to see like all the threads. You know, sometimes just based on, and this is all we pulled a bunch of different shackles from the field, from competitors and us. And every once in a while, you're going to see an extra thread cut. It's just the nature of how pins are threaded. It's, you know, with actuators, and they're pushed into the threading machine. And once in a while, you get a thread that's, you know, pushes it in a little too far, and you get an extra thread. That does happen. We take measures trying not to do that, but it does. But that would not be a rejection criteria. You're looking for that the threads are fully engaged within the body. Okay, but anything that's causing you concern, heat damage, weld splatter, you can't read the embossings on there anymore, or there's no traceability to a manufacturer. These are all things why I would discard that shackle. And if you're unsure and you're hemming and hawing about something, you're looking at something, and you know, I would always go on the conservative side and discard it. Say, if it's causing me any type of concern, hey, it's not worth it. I'm just going to go get another and toss this one out. So that's when I do inspections. You know, anything that's kind of fuzzy or gray area, I just ding it out of service. Okay. So again, the shackle that has a cotter pin, the cotter pins must be there. Those can easily be lost. Now you can use you know, a cotter pin. If you lose our cotter pin, you don't have to call us to get a cotter pin. Any cotter pin would do that fits in there properly, but that cotter needs to be in there for the bolt nut cotter style. So if it's missing, you want to get it on there, okay? And that will prevent that bolt from loosening or backing off. Okay? You can see here some things that we found in the field through training. Metal loss, basically that, you know, it doesn't fit on whatever they're trying to apply it to, so they grind the eyes down. Maybe they lost the pin, so they just go get I got a grade 8 bolt. You know, that, again, you saw how our pins and the criteria that it meets and things of that nature, and the embossing, you just can't put any pin in the shackle, even if it's all just for a quick lift. No, it's immediately out of service. Looking cracks, elongated eyes, you know, from overload, distortion. Again, more metal loss. You can see there extreme distortion. And again, if I saw that overload and things of that nature, to me, whoever was using that shackle, if I found that stuff that they weren't qualified, or if I saw they were using a ground, you know, the ground on it, or just using deformed shackles, I would question the integrity of the rigger and kind of make them go back through training. So one of the things that I do when I do inspections is you know, here's the things that I found that were in service that shouldn't have been in service, and then I always recommend that, hey, I believe your riggers need to get back to some training here, because I shouldn't have found those things. It really is the rigger's responsibility to inspect their rigging equipment and get them out of service, and not wait for a third party to do that. And so it just shows that the rigger wasn't qualified. All right, some safe rigging practices with shackles.
Okay. Peter, so, just before we start, I have another polling question I'd like to ask at this point. Sure. And the question is, let me just pull it up. So, what type of shackle style should not be used for overhead lifting? Is it the screw pin anchor style shackle, the nut bolt cotter anchor style shackle, the long reach nut bolt cotter style shackle, or the round pin anchor style shackle? What do you all think? What type of shackle style should not be used for overhead lifting? And let's wait for a few more to vote. The screw pin anchor style, the nut bolt cotter anchor style, the long reach nut bolt cotter style, or the round pin anchor style. And it looks like with about, I think 60% have voted, it's between the about 17%, 20% think the long reach nut bolt cotter style, and the other 80% think the round pin anchor style, Peter. So can you share with us the answer?
Yeah, the 80% is right. We mentioned that in the beginning. The round pin, it doesn't have a thread. It just has a cotter going through it. So that is not recommended for lifting. It's more for towing, load securement, tensioning, things of that nature, not for overhead lifting. For those that entered the long reach, no, the long reach or the chain style shackle, those are the ones that had to remain in line, that you can't do any type of side loading with that, which we'll talk about in a bit.
Okay, perfect. Thank you, Peter.
Okay. Again, rigging operations lifting operations are dangerous, right? We got suspended loads in the air, so we need to take precautions. One, we need to make sure that our gear is inspected, that we're not using the incorrect gear, then if we're using the gear correctly, and we need to be sure that our riggers are trained, okay, that they know what they're doing, okay? So when you're selecting any type of rigging gear, obviously we need to know how much weight is there, where our center of gravity is, the number of attachment points, any angles of loading, because what that will do is we can figure out tensions from there if we know our share of load, so we may not have to figure out some tensions, right? Because sling charts are nice because when we look at slings, the charts give us working load limits because they've taken in the tensions into consideration. Well, if you look at a shackle chart, shackle charts do not give you that angle of loading. They just tell you the working load limit of the shackle, or the shackle itself tells you the working load limit. So therefore, when you're going to attach to a shackle and your slings are coming in at angles, it's pretty safe to say you really need to know what the tensions are coming in so that you size the shackle properly. Shackles can be used in temperature ranges from 400 degrees Fahrenheit all the way down to negative 40 degrees Fahrenheit, and any temperatures above or below that, we recommend you contact the manufacturers to see what their constraints are or what their D ratings are, or even if at all they want you to use a certain style shackle in those environments. Okay? Shackles can be used as gathering rings, so that you want to place, so let's say like synthetic slings or that normally do not have what's called a master ring or anything like that you can connect them to a shackle and then connect to your crane hook to kind of make a bridle assembly. But we want to be sure that whatever we're putting in there is laid in there neat, that doesn't bunch up, it doesn't bind, and then we stay within the workable limit of the shackle. So again, we talked about this already, the D-shape or long reach shackle, they have to remain in line, and basically you're allowed maybe 5 degrees in line, but other than that, you want to keep the tensioning, and you can see those arrows in line at all times. Things to avoid, you can see there, when synthetic slings there, they kind of turned, and the shackle, that's not the way it was intended, so we want to keep that equipment in line. There are web saver type shackles and things of that nature that you can use. Now you can connect 2 web slings together, but you cannot do that with chain. The B39 and does not allow to connect slings together like that. But in the synthetic world, they do allow it. Okay. When connecting to eye bolts, we recommend you put a shackle there and not put a hook directly into an eye bolt because you can cause side loading or you can cause binding in there. So we always want to place a shackle into an eye bolt. And we have a blog on eye bolts as well, proper use of eye bolts, in our what's called cmcolive.com. I think we just did this blog not too long ago, Gisela, where we talk about use of eye bolts. So in that picture there, not only is the hooks within the eye bolts wrong, but the orientation of the eye bolt is wrong. We talk about putting a shim underneath and getting that orientation of the eye bolt into the tension. So you can go check that out, or Gisela, maybe in the follow-up we can.
I can include the link. We actually just published it this week, Peter. So yeah, it's very, very correct.
Yeah, so we can, everyone that's registered for this, we certainly can put that link in there, and you can read up on eye bolts. But definitely put a shackle in there so that your hooks fit properly, and then your shackle can articulate where your eye bolt can't. So it's just a safe way to use eye bolts. I strongly recommend swivel hoist rings even in place of eye bolts, but that's a whole other story and blog or webinar, and that, if you will, for that matter. Different attachments to shackles you can see here, wrapping or looping the chain through it, and that you can do that. You just have to take proper D to D reductions, which is the diameter of the chain compared to the diameter of the shackle, and chain has a D to D ratio, which it may reduce the working load limit of the sling if you're not at least 6 times the diameter of that shackle. Or you can see here, correct, there's the eye bolt with the shackle attached, and a hook can go directly in there. That's correct. Choking a web sling in an eye, that is not correct. That can definitely cause a knot in that sling and create enough heat where it can sever that sling, so that is wrong. So you can see there in the next one we would want to put a shackle there, and then we can connect a web sling then appropriately. Okay. So different types of connections, and again, you can see here where there's a lot of uses of shackles. When you're connecting to a pad eye, we recommend the best thing to do is have at least 50 to 80% of that shackle width or that clevis filled up try to avoid point loading as much as possible, because it does just a better situation. And everyone will ask us, well, what's the criteria for the correct pad eye or design of pad eyes or lift points? And there really is no safety standard that spells it out, or OSHA standard that spells it out. I would consult a qualified engineer for the design of that eye to be sure it's whole, and they can tell you how much weld and things of that it needs. But definitely you want to get lift points engineered and looked at. You know, the best I can do for someone if they're looking for a standard is advise them to look into BTH-1, which is the below the hook lifter standard, because it has some information in there. And but definitely want to have an engineer design, rate pad eyes or attachment points for sure. So different connections for the shackle. There are times where you may have to connect 2 shackles together for various reasons, whether you're trying to do a step down, or you're trying to lengthen maybe a synthetic sling that's a little bit too short, or for adjustment wise. So when point length shackles, we want to try to go bow to bow or bow to pin, and point length shackle the same size or the diameter of shackle that will avoid sharp edges, and try to keep the loading centered and in line. Okay, see how the orientations go, and if when what I always recommend when we train riggers to do is get the slings taut before you go to lift, and see how everything kind of renders itself. If you can kind of straighten out the shackles, and if you can't, then you want to kind of see, well, what kind of side loading is going on there, and derate your shackles appropriately.
Peter, why do we recommend not to rig shackles pin to pin?
Yeah, you can see there we don't show pin to pin. One of the main reasons is that that can slide around in there. So while you're lifting, when you think you're in line, you can get something that's off center, so which would derate that shackle. You can use bushings, spacers, washers to try to keep everything centered. But the ideal way to load a shackle is to center load in the bow or the saddle of the shackle on the pin, with mating objects close to the same diameter as the shackle of the pin or bolt. The ideal condition applies the load over a rounded surface of sufficient diameter to prevent cutting on the pin, and small enough diameter to allow the shackle to deform into a shape where the load is primarily intensile if overloaded. So, when you get too small pins, and if you're connecting something else to a pin, it just creates a point load that can cause damage to that pin, and really we don't want that to happen. And it's not always ideal or unavoidable to always have the 50 to 80% diameter. Severe point loading is to be avoided since a very small mating object of less than a quarter inch with the diameter of the pin or the bolt may have a tendency to cause localized material failure on the body or shackle or pin. So basically, a lot can go wrong when you go pin to pin, and so it can be achieved, but we desire something different, and so I would consult an engineer and things of that nature before doing pin to pin. But it is achievable. It's just something we just don't recommend. There's a lot of different It just creates more things to look at, I guess, when you make a simple lift more complicated than it need to be.
Okay, thank you, Peter.
So there you can see. Whatever we connected, you can see that the shackle quite didn't line itself up right, and so therefore, if I'm rigging, I'd have to look at that. If more than 5 degrees or 5% off in line, you may want to take a reduction of at least 30%. We have charts. You can look in our rigging books, our rigging guides, and things of that nature, where we have charts that will show you reductions in work moment based on the angle or the side loading that does go on in the shackle. You know, we try to avoid side loads, but not every application you can avoid it. It will happen. And so we you know, as well as the ASME V30.6 offers side loading reduction and information out there. So you want to make sure you get that information and derate your shackles properly. Here you can just see some improper loading on the pin, where maybe a sling is looped through, and they're going to slide that shackle along to find center of gravity, and it can loosen up the pin. So that's not, again, not recommended to do that. When you look at loading charts, when you're connecting two slings to an anchor style shackle, the working load limit is based on 120 degrees of included angle. I have another slide that shows that, so it's kind of symmetrical loading that you're getting the full working load limit of that shackle. Okay. Again, we want to avoid the slings from being bunched. We don't want to cram things in there because that's just going to cause damage. So what was I talking about with the 120 degrees? So you can see here on a crane hook, when you connect to a hook, okay, if you're connecting two slings, you're coming in and you're connecting two slings to a hook, you want to stay within that 9 degrees, which is a 45-degree horizontal angle minimum coming to the hook. And if you can't achieve that, then you're going to have to place a master ring over that hook or use a shackle, which allows 120 degrees of occluded angle, which is 30 degrees from the horizon. When you're doing chokes, now chokes can cause a lot of friction. So if this is a choke hitch, and choke hits by nature reduce the working load limit of your sling, at least 20% if you render your choke properly per the charts. However, it causes friction in the running part of the choke, basically where you're lifting with the crane. That part of the sling can cause friction, and so when you use just a sling on sling, you can get a lot of rubbing and wear. So a shackle eliminates a lot of the heat and a lot of the pinching going on, and so it creates a nice attachment for that choke there. Here's the charts I was referring to, and we get a little bit more detail on our loading charts, but basically if you're beyond that 5 degree, 6 degree to 45 degree, you get 30% reduction in the work limit. And we have information of stuff in between to kind of fine tune it, but for this purpose of this webinar, we're just kind of going with this. 46 degree to 90 degrees, at least 50% reduction. And again, we do offer more detailed side loading in our rigging catalog and also in our pocket guides to show you that. So you can see there, that's the anchor style, whether it's a screw pin or bolt nut cotter anchor style shackle for side loading. We're not going to use the chain style or the D-shaped shackles when any type of side loading occurs. Again, those always have to remain in line.
Okay, I've got my final polling question, Peter. And the question is, what type of shackle must always have loading in line? Is it the chain long reach D-shape, the screw pin anchor shackle, the nut bolt cotter anchor style, or none of the above? So if you can let me know what you all think. Oh, it looks like it's, I'm just going to give another couple seconds here. Okay, about almost 70% have voted. 90%, Peter, think chain long reach. 5% think screw pin anchor. And then a couple more split between the final two answers. So what is the answer, Peter?
Yeah, the chain style long reach always have to remain in line.
Okay.
So that's important. You can distort that shackle.
Great, thank you.
Okay, so we talked about D to D for a little bit, and this is wire rope D to D. Why I want to mention this is because a shackle oftentimes is used to connect wire rope. And so basically you have these D to D reduction charts. Most of the time the charts that you see have a 25-to-1 D to D for the working limit of wire rope. So the large D is the diameter of what is placed in either the eye or the body of the sling, and the small d is the sling itself, and that would be the same for chain as well. So you can see here some different applications. So there, when you see a shackle connected to an eye of a wire rope, you always want to, we train and use a larger shackle than the diameter, but in reality it's got to be equal to or larger than the diameter of the wire rope of the shackle that you place to the eye. The reason being is you can distort the eye if you use something smaller. Okay, so because basically we talked about that with point loading for pin to pin. So the point loading can distort that eye. So you want to be sure that the pin is large enough, or the shackle body is large enough, or matches the diameter of the wire rope. and then you can see all the way to the right there, if you're using the same size shackle in that configuration, you're going to get a 50%, or at least a 50% reduction in that sling there because it would distort. So there's where you would require a 25-to-1 ratio of what you're placing in there. So just different things to be aware of that we touch upon in our rigging training and go into detail. Here's the D to D for chain, and a chain is at least 6-to-1. So the chain diameter itself, the actual diameter of the links, compared to the diameter of what you're going around, has to be 6-to-1. So remember, if you're looping chain through a shackle, you want to be sure you take your proper reductions for your sling, so you don't damage your sling.
Okay, Peter, I'll take it from here. We have 16 questions for you, plus a few that I'm going to have you directly email people answers to. So the first question, Peter, is I was wondering what the proper orientation of 4 shackles on a hook or master link when the headroom is an extremely restricted application. Are they all bow up, down, or 2 up and 2 down?
We recommend bow to sling. So whatever you're attaching to, maybe I'm misunderstanding. Maybe they're using all shackles for that situation. So
yeah,
really, if you have
4 shackles on a hook or master link, and are they all bow up or bow down, or 2 and 2?
What I would do is, it really doesn't matter, but what's best what would work to keep those shackles centered, so that in line, so that you don't have any of them. I would take a look at if it orientates. Any of the shackles just tend to orientate any differently. You want to be sure to keep those in line for that. So it can be, it really doesn't matter. There's no set criteria for that. I would be more worried of keeping everything in line on those.
Okay. All right, question 2. We've got a few people that have kind of touched on this, but there was a question about the mouse tailing. If it's possible to provide an illustration of what a mouse tail should look like, and can zip ties be considered acceptable for mousing the screw pin, or potentially even plastic wire ties?
Yeah, I would think a zip tie would work, or a wire or anything like that. Anything that can hold that pin from articulating or backing off or becoming loose. But yeah, maybe we'll do a picture of one and just kind of show an example. We don't have a picture yet, but I can easily do that for you. But yeah, sure, zip ties would work, plastic wire, but something. Again, there's no excuse me, set criteria of what the diameter or how strong it needs to be. It's just a safety rule of thumb.
Okay, great, thank you. What about GAC Flex slings for overhead lifting?
Say that again?
What about GAC Flex slings for overhead lifting?
Not familiar with GAK.
Okay, we can maybe follow up on that.
I'll have to restate that and answer that offline.
Perfect. Why the difference with super carbon?
Super carbon has alloying elements in it, and so it gives us higher strength over a standard carbon shackle and keeps the cost down over an alloy shackle. So we get something better out there in the industry that is cost effective and stronger and holds up better in shock load.
Okay, great. Why are shackles not held to the same criteria as alloy chain and components for overhead lifting?
Very good question. Honestly, I don't think I can answer that question. That's just been. It's just the way it has been. I don't know really. I could offer my opinion, but it's just.
Yeah.
I honestly don't know why. It just is. It's a different
So
standard. We have a B. Yeah, we have a B30.26 standard, which is rigging hardware. We have a ASME B39. OSHA was their 1910-184, and they don't even mention shackles in OSHA. So something that chain manufacturers always came out with alloy, and 1935 we came out with alloy, and we just always recommended alloy for overhead lifting, and really didn't address shackles up to that point. But alloy's always going to be your best. If you want the best, stick with alloy. That's going to be your best. But you can use carbon or super carbon.
Okay. All right. Why the increase in safety factor for only one type of our shackles? Why not have a higher WLL on 5-to-1 instead?
Great question. I'm not sure if it's more of a marketing thing or not. We'll refer that question
Follow up.
to our head engineer in Troy, and we'll answer that
Okay. Got it. Let me
offline.
just make
I do not have an answer.
Okay.
Yep.
Okay. So,
It's and just real quick, when you're coming out with a new product, like a super carbon, it's obviously something that was new for us at the time, and so when you're designing something new, you want to make a splash initially. So hey, if we can make it 6-to-1, that's definitely one of the criteria. Hey, we want to sell this. If we feel this is a better shackle, we'll make it 6-to-1. We'll call it super carbon, and so again, you try to get a competitive advantage.
sure. For a 2-inch flat synthetic web sling, there is a flat bottom shackle designed for that type of sling. Is there a similar shackle for a 1-inch wide flat synthetic web sling?
Yeah, there are web lock slings out there for various types and sizes of shackles. So there are a bunch of different styles. The ones the ones I showed in this presentation, I didn't show any web lock style at all in there, but it's called a web lock shackle. So you can do some research on that and find certain shackles for that.
Okay. And this goes back to, I know we kind of touched on this a little bit, how deep of a stamp you've talked about already. Hold on a second. And you talked about stamping the shackle with a punch. You already touched on that one, so let's see. Will CM start offering laser etching on shackles?
That's something we can certainly look into. I think we may have done even some of that already. So I certainly think we could as a special. So it's not something standard that we would do, but we certainly would entertain that option.
Okay, let me just make a note. All right, and there was a question about the deformity of that one shackle, which I guess this person thought was a Crosby shackle. Can you explain the process that a CM shackle goes through? Like I said, that one was deformed. Explain what happens with a CM shackle if it's overloaded.
Well, yeah, CM shackle will tend to deform and not break. A shackle tends to break in the eyes. And so a CM shackle will tend to elongate and before rupture. So you'll see a lot more elongation, especially in the super carbon over a carbon shackle, where the eye won't break or shatter. There is, matter of fact, so there is that we have that the video which we can show people that very same thing, and it's so we can include that in the link where we put the two shackles head to head in the test stand?
Yeah, I'll tell you what, that's in a blog article. I'll put a link to that blog article too. That's a good point. I was thinking this.
That explains that very well.
It does. It shows it. So, does the certified rigger have to inspect every shackle before each show, or just inspect in batches?
No, you should expect. No, they should inspect every shackle. The rigger because again, that shackle is being applied. Written records don't have to be kept, but you have to physically put the shackle on something. So that rigger should be looking at that shackle. It only takes less than 30 seconds, even if that, to look it over before you attach it.
Okay, thank you. Let's see. Let me just see. Next one. Can a hairpin keeper pin be used in place of the cotter pin?
Yeah. Yes, it could.
Yes. Let me just make a note. Okay. When placing a shackle into use, would you address the complete engagement of the shackle pin versus backing it out a quarter turn?
Yeah, there's been a lot of misconceptions out there where when you tighten a shackle down, that once you have it tight, that you back the pin off a half turn or so, and that's been out there. No manufacturer agrees with that. No manufacturer will state that. B3026 actually says that the shackle pin shall be tight. The head of the shackle should either engage the body or you have full thread engagement, like I talked about. But it does not mention at all backing off the pin. So backing off the pin has been out there for years. Riggers, I think, did it because it makes it easy to take the shackle off, but the screw pin when you're done. instead of having to have a spanner wrench and prying it off. But all manufacturers do not recommend backing off.
Okay. And just so you know, I know we're running over time, and we're so thankful that you all came today and participated in our webinar. We understand that if you need to go, you can go, but we also want to make sure we address every question that's asked so that everybody here can benefit from that. So we're going to continue to answer all the questions that come in, okay? So what does the term fully seated mean? Which end determines this? The outer end where the threads are, flush, or where the pin is inserted, where the arrow indicated in the previous slide 28?
It's where you want to look where the pin engages the shackle body. So we're talking about screw pin shackles, and on the body itself, the ear, one of the ears is threaded, and so that you want that pin to be fully engaged on that ear or the eye, all right, so that when you look at that eye with the internal threads, that pin will either be flush on the other side of that eye, or it might be sticking out just past it a little bit, which is fine, but you should not see any recess of that pin within that eye.
Okay. Next question. I rig suspended scaffolding. Would that be considered an overhead lifting application?
Yes. The scaffolding is a load in itself, and it's a suspended load, sure.
Suspended load. Okay, great.
Unless they have redundancy and they tie it off where it's, there's something that rigid holding onto, but if it's just slings holding that scaffolding in place and nothing else, that's a suspended load.
Okay, great. All right, is there really any reason to offer round pin shackles? Couldn't I use a screw pin shackle or bolt nut in the same application and be safer?
Yes.
Yes. Okay. All right.
I mean, the round pin is more of an economical, hey, I'm just going to be pulling some stumps, or hey, I'm towing whatever, a car or something of that nature, or, it's just more of an economical use for it. But yeah, you're anything that's threaded with bolt nut cotter and you have engagement is a better choice.
Okay, perfect. Yeah, there was a question about trademarks. I will address that question directly. I work in a state facility, and this is another one, Peter, that I'm going to direct to you specifically. It has to do with poor rigging and poor rigging training, and how he could best address this type of, how he could best add in safety protocols. But I'm going to have you directly answer that one via email or phone call. Okay.
Yeah, the short answer is just to get properly trained and certified in rigging.
Yeah. Okay, but like I said, I'll send you his contact information to follow up. Pin up or pin down argument. Yeah, we've already talked about that. Let's see. Okay, what is your opinion of the folklore? If you drop a shackle, you must discard it.
Unless you drop it and it creates a nick or a gouge or any type of damage. But if there's no damage to it, you look it over and there's nothing wrong with it. You're good to go.
Okay, perfect. Yes.
I guess every drop, dropping it from 5 foot would be different than dropping it from 40 feet. So you just gotta inspect it and make sure no damage happened.
So it just depends. It depends on the situation. Right. Okay.
Right.
All right, and then we did get someone to comment that the GAC Flex is a trade name for an aircraft cable core round sling, like span sets, steel set slings. Yeah, it's a GAC Flex round slings as opposed to poly. So if that helps. And yeah, I guess the person typed it in wrong. It should be GAC Flex. So I hope that helps. All right, a metal wire sling surrounded by your typical sling fabric used in entertainment industry to rig motors. All right, so that being said, Peter, I forgot what the question was, but it was way up here. Well, we'll do a direct answer on that one as well.
Yeah, because I know a lot of great entertainment riggers, and we can have them answer that question.
Okay. Yes. And CM offer webinars. I know we've had a couple questions about receiving credits for these sessions. We're not able to do that. We have online training you have to pay for that Peter offers where you could earn credits, but unfortunately these webinars we're not able to give you that. Okay, and I think we have one more question. Is there a shackle capacity reduction required if using on a multi-leg sling pick and the load is asymmetrical?
Yeah, you'd have to look at your tensions and things of that nature coming in. You may choose to, this is what I would do. So if I have an asymmetrical load coming in, I may choose to connect it differently. It depends. I'd have to look at the situation and to see how the loading would be. So basically, we have a vector and two different forces. So what my resultant force would be is I'd have to look at it. It's a little bit more advanced rigging for that. But I would recommend just maybe even going to a master link or something of that nature and connect, doing a little bit different connections.
Okay, very good. All right, and we've got some comments in from some other people, and thank you for those. Yeah, and I think this is actually, Larry, you bring up a point that comes back. We get questions about this on our blog quite a bit. If we have a product and someone wants to substitute a part of the product with a competitor's, the answer is typically no. We get this question a lot, of course. So yeah, if at all possible, always. I mean, I want to.
We can only guarantee our products and what we say. I'm not, I don't work for any of the competitors and things of that nature, and I'm sure they would say the same thing.
Yes. So
I can only verify the workmanship that CM does, and I would not want to speak for another manufacturer.
Okay. All right. So that is all the questions we have. We can just continue and wrap up. So we appreciate you coming on the call today again. And Peter, if you can just advance one more slide. We just want to share with you some of the training we have coming up in case you might be interested. This is, by the way, how you can reach me directly. Yeah, but go ahead. Yeah, so go ahead, Peter.
Yeah, we do have online training. For those that have taken hoist repair, we have an ET version for Lodestar. We have our industrial hoist version. We have overhead crane inspection recertification. We have overhead crane, the initial course you have to take before that on recertification. We have one come up in Charlotte, North Carolina in March, the 7th through the 9th, which is where Gisela is.
Yeah.
We have the Qualified Rigger course, 3-day course coming up in March 21st to the 23rd. Actually, we have one going on next week here, so anyone near Buffalo that wants to get in it, we have some room. You're welcome to come. It's starting next week, Tuesday. If you can get here, great. We'd love to have you. And then we have another one. The next one is in March 21st to the 23rd. And also, if you want to be, for those crane operators that want to come, what we do is we add in a couple days to the course for crane operators so that they get crane time, run the cranes through obstacle courses and from different heights, from the floor, from 2 stories, mimic a cab operation, and then you're required to take certification exams at the end to do that. So it's a little bit longer than our 3. We have our qualified rigger, and then we have a crane operator, which is overhead cranes, by the way. Gisela, you've been through that course, and it's quite intense that we put the operators through. Or here in the Niagara Training Center, I get asked a lot, can we do this on site? And I always decline because we really can't get the crane time when we're working in a production facility that we need. And we utilize these cranes throughout the training all weekend, and whenever we want, and whenever someone has questions, we don't have to wait for operations to be done or, hey, you can't have it now. So each person gets good amount of time on those cranes.
Perfect. And then just to the last slide, we just want to show you can connect with us in a multitude of ways. We're on, for those of you on social media, we're very active on really all the channels that you see listed. We have 2 Twitter accounts, one for entertainment, one for our general industry. We have all of our safety webinars on our YouTube channel, along with many other product videos, how-to videos for hoist and rigging and crane operation. We're very active on our Facebook page, LinkedIn, Google+, Instagram. And the green icon is our blog, and you can find all these icons on our CMWorks website. If you click on them, it'll take you right over to our social media channels. So thank you again for coming today. If anyone has any final questions, you can always respond back to the email that I sent, and I'll forward them on to Peter. So thank you. We appreciate your participation, and hope you join us in March for our next safety webinar, title to be announced. Thank you.